Division can seem tricky, but with a few simple tricks and this step-by-step method, you'll master it in no time. Division is basically the opposite of multiplication. When you multiply, you increase a number by repeating it several times. In division, you do the reverse. You take a big number and break it down into equal parts. If you've watched my multiplication video, you already know how the reverse connection works. And if you haven't, feel free to click the I button to check it out. Division is usually represented by this classic division symbol, sometimes by a slash, and in long division by this horizontal bar structure, which we'll soon use to break down larger numbers. Let's begin with a simple one. Say you have 12 divided by 4. What that really means is, how can I split 12 into 4 equal parts? If you've memorized your 4 times table, you'll immediately know that 3 times 4 equals 12. So, the answer is 3. Simple. The idea here is that division and multiplication are like best friends. One grows the number, the other shrinks it back. Let's warm up with a few quick examples. What's 40 divided by 8? That's 5, because 8 times 5 gives 40. Now, how about 35 divided by 5? That's 7. And 81 divided by 9? That's 9. If you know your times tables, you can simply find the missing number that completes the multiplication. The division answer is just the number that was multiplied to get the result. Sometimes division problems don't solve themselves so easily. Take 46 divided by 2, for example. If you glance at your 2 times table, 46 doesn't show up directly. So, what do? This is where the long division method comes into play. Write 46 inside the long division box. That's your dividend. Place the 2 outside. That's the divisor. And as you solve, you'll build your answer, the quotient, above the line. Now here's something interesting. In most math operations like addition, subtraction, or multiplication, we work from right to left. But in division, we flip that. We move left to right. So, start with the first digit of 46, which is 4. Ask yourself, how many times does 2 go into 4? The answer is 2. Write that above the line in the quotient. Then multiply. 2 times 2 equals 4. Write that below the 4 and subtract. That leaves 0. Now bring down the next digit, 6. Ask again, how many 2's go into 6? That's 3. Write it in the quotient. Multiply. 3 times 2 equals 6. Subtract, and again, we get 0. No digits left to bring down, which means we're done. The final answer is 23. This process is called DMSB. Divide, multiply, subtract, bring down. It's your core loop in long division, a reliable step-by-step method we'll keep using throughout. Now it's your turn to try a few. Pause the video here and test your skills with these 3 problems. 51 divided by 3, 262 divided by 5, and 1,872 divided by 9. Let's walk through the first one together. 51 divided by 3. First, I'll set it up using the long division box. Remember the setup. The dividend goes inside, and the divisor sits outside. For 51 divided by 3, we begin with the leftmost digit of the dividend. That's the 5. Now ask yourself, how many times does 3 go into 5? Well, 3 times 1 equals 3, and 3 times 2 equals 6, which is already too big. So, we can't use 2. This is a key idea. When dividing, we look for the largest possible multiple of the divisor that doesn't exceed the digit or group of digits we're dividing into. But also, avoid going unnecessarily low, unless the only option is 0 or 1. So in this case, 3 fits into 5 once, and that's the best we can do. We write 1 in the quotient. Multiply. 1 times 3 equals 3. Now subtract. 5 minus 3 equals 2. Then bring down the next digit from the dividend, which is 1, giving us 21. Now repeat the process. How many times does 3 go into 21? That one's a perfect fit. 3 times 7 equals 21. So we write 7 next to the 1 in the quotient. Multiply and subtract. 21 minus 21 is 0. There are no more digits left to bring down, so we're done. The final answer, 17. Next, we have 262 divided by 5. The first digit is too small, so we consider 26. 5 fits into 26 5 times, which gives 25 and leaves a remainder of 1. Bringing down the next digit, we now have 12. 5 goes into 12 2 times, giving 10, and leaves 2 behind. There are no more digits to bring down, so the division ends here. Since something is left over, we call it a remainder. So, the final answer is 52 with a remainder of 2, written as 52R2. Now for the last one, 1872 divided by 9. Starting with 18, 9 fits into it exactly twice. Subtracting gives 0, so we bring down the next digit, 7. Since 7 is smaller than 9, we place a 0 in the quotient and bring down the next digit, giving us 72. 9 goes into 72 8 times exactly, with nothing left. So, our final answer is 208. Now, let's try dividing with two-digit divisors. Consider this example, 2,164 by 12. Now, there are several ways to do it. One thing to remember that there is no more default timetable for numbers more than 10. The first method you can do is to create a times table of 12, more like a rough table, or any divisor you are dividing by. Now, since 12 is a two-digit number, you will select the two leftmost digits, 21 here. Now, if you look here, 12 itself is the closest to 21. So, place 1 in the quotient, place 12 below 21, and subtract, giving you 9. Then drop the next digit. Now, 12 times 8 fits into 96 perfectly. So write 8 in the quotient, multiply 12 and 8 to write 96 here, and then subtract to get 0. Bring 4 down below. But here's that same shortage problem from before. But here, since there are no more digits to bring down from, we use 0 in the quotient, as any number multiplied by 0 is 0. 4 minus 0 is 0, 4. So the answer is 180 R4. Let's try one last big example. 945,678 divided by 84. Again, create a rough table of 84 to help estimate. Starting with 94, the closest multiple is 84, so we place 1 in the quotient. Continue using DMSB method through each step. I'll fast forward through the process here. And we're done. That's all, folks. If this video helped make division clearer and easier, please hit like and subscribe for more math tricks. See ya!